there is one very big weakness to Orchestrator. It has no way to evaluate if the draft is good enough or not. What is if the final draft that is being shared with the user is not up to the standards? We need a evaluator loop in such cases. Let's talk about the evaluator pattern now. So evaluator is nothing but an agent or a language model that evaluates the output coming from a generator, and that generator could be an orchestrator, something that generates a response. So let's see how it works. So there's a query from the user. It goes to something we call a generator, which is generating the response, and the response doesn't go to the user directly. The response goes to evaluator, which is essentially the critic. So evaluator is nothing but a pattern that works on generate and critique pattern. Generator generates a response, evaluator critiques the response, finds out all the weaknesses, all the problems, all the mistakes in that response, and sees if the response is good enough or not. So if it is not able to find any mistakes, any problems, any issues with the response, it would, let's say this is a decision tree, so good enough. If the response is good enough, if yes, the task is done, and just stops and returns the response to the user. All right, so generator generates a response, evaluator evaluates it, critiques it, and if it's not able to find any mistakes, if it thinks that the response is good enough, in that case, the response goes to the user. But what if the response is not good enough? In that case, the evaluator essentially writes the specific feedback as well as provides a score against the response, whether it's out of 100, for example, how is the score? How would you evaluate the score? So if it's 80, 90, something like that. So it scores the response, finds specific feedback to provide to the generator that again improves upon that response in a loop. So provides specific feedback and it scores the response as well. And we'll see why this scores helps the system. The generator looks at its response, looks at the original query, has all the steps that it performed, all the historical data. Then it would use the feedback to improve upon the response. Sends the response number 2 to the evaluator, which again critiques it. If it's good enough, then yes, done, send it to the user. If it's not good enough, then send it back to the generator with more specific feedback and score. Now, what if the evaluator is a perfectionist? It's never happy with the response. For that, we have something called maximum retries. So we provide a ceiling to the number of loops it can do. And it also depends on the scores. So basically, we can design the system in such a way that there is something called a maximum number of retry, so maximum number of loops, and there could be a threshold on the scores. For example, if the threshold is 90, so if the response reaches a score of 90, then just get it done with. It's good enough. So this score can be used to determine whether it's good enough or not, and we can adjust that score depending on our requirement, depending on our testing. Again, another use of that is, let's say it reaches the maximum number of loops, so maximum retries, and even if it's not good enough, it reaches something called max retries. In this case, the code will say, okay, maximum retries reached, find the best response out of all the past responses based on the score and return that response to the user. All right, so that's all about this evaluator loop. Let's understand with the help of an example. So let's say, again, working on the same example of a code generator. Generator generates the piece of code with all the comments, documents, and documentation and so on. The evaluator finds that there is a bug in the code. it's not good enough, goes back to the generator saying there is a problem, there is a bug in this part of the code, improve upon it, there is another problem, and so on. After response 2, it finds that the code is not documented well, or the variables are not named well. In that case, it will go back to the generator with that feedback and so on. All right, so we've talked about how an evaluator works in the system of AI agents. How do we determine whether this particular evaluator is good enough? So an evaluator is good enough if it is very specific. So there could be some use cases that we are trying to solve in which we have some specific criteria on which we are trying to evaluate the response of a generator. So that specific criteria is provided to the evaluator. It's nothing but a prompt and an LLM, like a simple agent. So we provide that criteria to the evaluator. And the more specific the criteria is, the better our evaluator would be. So in this case of a code generator, the criteria could be the code has to be bug free. Criteria number 2 could be it has to be well documented. Criteria number 3 would be it has to be well modular. And criteria number 4 would be it has to be well tested, all the base cases are covered, and so on. We could have all different criteria. So the more specific these criteria are, the better the evaluator has to be. And we know on the basis of this specific criteria whether we need an evaluator or not. If we are solving some generic simple problems in which we don't judge essentially on specific criteria, in that case we can just include that smaller criteria. For example, the response has to be very neat, or the response have to be very succinct, very clear. We can provide those criteria here within the generator, and we do not need an evaluator in that case. But if the problem is complex enough, we need to separate. There has to be a separation of concerns, and we need to separate the generator from evaluator. The generator has to be creative, has to build, has to produce a good response, but the evaluator has to be very harsh, very critical to find mistakes. So in those cases in which we need to have a specific criteria to evaluate the response and it has to be strict, in that case we need a we need an evaluator to evaluate that response, and only if it passes those criteria, it's sent back to the user. All right, so the summary is we need an evaluator only when the problem is complex enough. The problem has to be correct more than not, and there is a strict criteria on which we are judging the response of the generator. In those cases, we need evaluator. Otherwise, we do not need an evaluator. We can provide a few lines within the prompt of the generator saying these are the criteria on which you can judge. All right, so this is the generator evaluator pattern. This generator is, let's say this generator is an orchestrator. So we'll talk about different patterns which can be designed using orchestrator generator mechanism. All right, so orchestrator would plan, replan, judge its response of the previous step, and decide the next step based on the response of the previous steps. So it would create steps or create plan on the fly, and then produce a single output. Step 1, step 2, step 3, and each step is decided on the basis of previous steps, and so on. But the response is one single response, and it does not evaluate the response, whether it's good enough or not. In this case, the first pattern would be the orchestrator responds, the evaluator evaluates the response, the evaluator evaluates the response, and then sends it back to the orchestrator saying whether it's good enough or not in the previous pattern. So we can have an evaluator evaluating the response of all the steps within the orchestrator. So step 1, step 2, step 3. So the final response is evaluated by the evaluator. But what if this is too complex? Why? Orchestrator runs different steps to solve the problems, right? It could be 10 different steps. The response is the final draft or final response that is sent to the evaluator. The evaluator sends back with the feedback to the orchestrator. The orchestrator runs all the steps all over again, calls different agents to be able to solve these different steps, and then sends it back to the evaluator. There's some problem with this system in that there are too many LLM calls because the orchestrator is solving for all the steps. So there are too many LLM calls, too many agent calls, and evaluator evaluates only the final outcome. There's some cases in which final outcome only matters and there could be a mistake anywhere in any step. In that case, this pattern is good enough. But what if we want to minimize the cost, minimize the latency, so we want to minimize the LLM calls? In that case, if we don't want to evaluate upon every single final response because there are too many LLM calls within the orchestrator, in that case, the orchestrator there could be a different pattern. Let's talk about that pattern. So in this pattern, evaluator evaluates the final response of the evaluator. So the evaluator is outside the orchestrator. But in the next pattern, in the second pattern, the evaluator is not outside the orchestrator but within the orchestrator. So let's say this is the whole evaluator in this case. Evaluation in a loop. But what if orchestrator step 1, step 2, step 3 may be good enough, and we found during testing that some of the steps do not need evaluation. They are not complex enough, or we do not have strict criteria to judge those steps, and we need evaluator maybe in just the final steps, step 4 and step 5. So we need evaluator. If we find that we need evaluator only in a few of all the steps, then we will save our LLM calls, we will save latency, and we'll save the cost in the LLM calls, and we'll call the evaluator only on a certain set of steps. So when step 4 is happening, there is a certain evaluator defined, evaluator 1, evaluator 2. These could be different or same. And this whole thing runs in the evaluator loop that we talked about and separate from this whole thing. So there are only 2 loops here in this pattern, and we do not have any evaluation loops in these 2 steps. This is called as having evaluator within orchestrator. So this is pattern, let's call it pattern A, pattern B, and let's call this pattern A. In this pattern, we have evaluator outside an orchestrator judging the whole response. So basically it's being applied to the whole orchestrator, and meaning every single step of orchestrator will have a retry. In this case, if every step does not need an evaluator, then we have evaluators tied to specific steps of the orchestrator, pattern B. In practice, pattern B is more common because pattern B has fewer LLM calls, fewer agent calls. It has less latency, and in most of the use cases in practical world, not all the steps of an orchestrator, not all the steps of a problem might need an evaluator, might have strict criteria to be able to warrant an evaluator, and in those cases we just tie the evaluators to specific steps. Now you might say that, okay, you're saying evaluators are tied to steps, but the steps are decided on the fly by the orchestrator. So how do you tie evaluators to the steps in practical? Basically, I want to clarify this, that evaluators are in practical tied not to steps but to the agents. So if this step 4 needs agent A, then evaluator A, which is tied to that agent, is called, otherwise it's not called. So whatever agents are basically connected to the evaluators and not essentially the steps, because the steps are not pre-decided in the case of an orchestra. All right. So to summarize, evaluator is evaluating the outputs of a generator. The generator could be any AI system. It could be an orchestrator or a router or any system. Evaluator is needed only in specific circumstances, but most teams these days do use evaluator to evaluate the response and ensure that the response is good, of high quality, meets the criteria that we have set. There are 2 patterns that we talked about when we are using evaluator, pattern A versus B, when we are using evaluator with an orchestrator. And that's how I would conclude our discussion. I hope this gives you a good picture on the whole AI system, how it moves from single agent to multi-agent systems, different patterns, moving to the final pattern in the series, which is evaluator, and how it works in practice.